This video is for the osmotic pressure. I'll remind you at the end, but I do want you to stop once you complete page 22, okay, in the discussion. I don't want anybody to go any further than that. It's not going to show 100%, but once I see that you've completed page 22, I will manually update your grade to give you full credit, but I do want you to stop there. So there's some, introduction material as always. We're using an osmometer in order to calculate the pressures that we need here. And the pressures are in milliatmospheres, okay? So normally we're not used to seeing osmotic pressure. The osmotic pressure that we show you how to calculate is simply just this I factor, right? Looks something like this, but without the rate and without, or the gas constant and without the temperature, we say osmotic pressure is equal to the I times the molarity, and that can give us some rough estimate here. But for the lab here, we do want to use the full formula for that, and I'll definitely show you how to use that. And then just remember I is equal to the number of ions, and if there's no ions, then I is simply equal to just one. So for looking at something like sucrose doesn't have any ions. But the other, this here, the TABF4, this does have two ions, and I'll show you that in just a second here. So we'll definitely need this formula here for osmotic pressure. And then this is a new way that I'm gonna show you how to use this. It's just kind of a sample equation here, but we can see it right here. So Y is equal to the molar mass, or grams per mole of some substance. That's what Y is equal to. So the formula is the molarity is equal to the mass in grams divided by the molar mass of the solute divided by the volume in liters. So I've already rearranged the formula for you. So this is the formula that I want you to use when we're going to calculate the molar mass of the solute, right? So we're going to take the mass in grams of it divided by the uh, molarity of it over the times the volume in liters, multiply that by 2, and that will give us a pretty good calculation for the molar mass, or what we call Y here. But you don't need it for this page here. This page here, you're simply just, they give you the formula here, C6H12O6, right? This is our chemical formula for glucose. So you can simply just use your periodic table, calculate that, but they do want it rounded to two significant figures, right? We don't want to just put 18. We do want to at least make 100, not just 18. And we can just continue on from there. And this is the reagent that I was talking about down here. And we notice that for here, I is equal to the number of ions, that this will form two ions. So our I factor, when we're looking at these values here for this particular reagent here, is going to be 2. I is equal to 2. For sucrose, I is equal to 1. So we are going to be recording the masses of it. So don't forget to bring your equipment down from down here. I do just want to show you the water real quick. I'm just going to put some water in here. When it's asking you to load the osmometer, I think you're supposed to fill it up to 400, but I don't need quite that much to show you. So here I'm going to drop 40 milliliters. It doesn't matter which side, you're going to need to fill both of them up. So 40 milliliters is going to go in here. And 40 milliliters also goes in here. So remember that there is 80 milliliters. 80 milliliters used for the volume. The volume you're going to need to know down here. But in here, you do have to convert milliliters into liters, right? So we just simply divide that by 1,000 and we'll have that volume in liters. So please make sure to remember to do that or your calculations will be way off. And then you'll load the sample. The sample is going to be loaded, the one with a funnel. That's going to be the one that you're going to load here, right? You're going to take the sample, put it over here, and then you're going to dump that sample into there. You're going to make sure record your initial temperature. Let's get to that page. It's asking you to record initial temperature in degrees Celsius. So whatever you see here. Normally I just use 30. It really hovers around 30. So that's just to make the calculations easier. I just end up putting 30 degrees Celsius in here. And again, just a reminder that these are in milliatmospheres. Okay. You'll let that run for a few minutes. Um, and then when it's done, you'll collect the pressure that it says here when it's done, and you'll record that. And you'll do that again for the sucrose, and then you're going to do it again for the unknown protein, collecting all that information as you go. And then we get to the discussion portion, right? So the experimental portion is pretty simple, but we do have to make calculations here. Like here, it's asking us in atmospheres what that pressure is. But recall that what we had was in milliatmospheres. So 1,000 milliatmospheres equals 1 atmosphere. So divide that value that you recorded on your data sheet for this pressure divided by 1,000 to get the number of atmospheres. So don't forget to do that. It's asking you for the temperature in Kelvin. Notice that this is degrees Celsius, right? So don't forget how to convert that degrees, or I'm sorry, Kelvin is equal to 273.15. Plus whatever the degree Celsius is going to be. Normally it's 30, so 273, 303.15 degrees Celsius. And then it's asking for the I factor, which I reviewed a couple times already. Our I factor for this is 2 because we did see those 2 ions earlier here. So when this ionizes, we get 2 ions. And now we need to calculate the molarity of it. So you're going to be using this formula here. I've already rearranged it from this problem here. So osmotic pressure in atmospheres divided by all of this, our I factor of 2, the rate constant which I provide you here, and the temperature in Kelvin that you previously just calculated. And you'll be able to calculate the molarity of that. Moving on, it's now asking you to calculate the molar mass, our grams per mole. So use this equation in order to calculate that molar mass, or grams per mole, which is equal to Y. Y is the molar mass. That's our grams per mole. So we take the mass of grams that we weighed here, divide by the concentration that we just calculated, and the volume, remember, 40 milliliters here, 40 milliliters here, 80 milliliters, but convert those milliliters into liters, okay? Very important, or you are not going to come out with the correct answer. All right, moving on, I believe you do that for the other ones as well. So yeah, same thing here, the molar mass of sucrose. How do we do that? Well, from the previous page, you're going to follow the same steps. You're going to calculate the molarity of sucrose by using this here. But for sucrose, recall I is equal to 1, not 2. But you use the pressure in atmospheres, not milliatmospheres. The temperature still the same. The rate's still the same. The I factor is changed to 2. And then grams per mole. But we have this formula here. The mass of sucrose, the concentration of sucrose, the volume, which is still again 80 milliliters, converted to liters times 2, and that will give you your value there. And then I believe you do it here again, one last time for the protein. And I'll tell you right now, for the protein, it's going to be huge. So it might seem like an odd number, but it should, I believe, be in the 20,000 range. So please make sure, if you calculated it correctly, you should be in that range of 20,000 something. Okay. So that'll kind of let you know you're on the right track. And that's where I want you to stop, right? We're at page 22. Stop. Do not go any further than this. Don't worry about this not being 100. I will manually change those once you've completed the lab. Okay.